let's convert some more decimals into their p by q forms. Let's start with 0.123 bar. So x is equal to 0.12333 and so on. Now, by which number do we multiply x? Let's multiply with 100. And doing so, we will get 100x is equal to 12.3333 and so on. Now, if we subtract x from 100x, the digits after the decimal point will not be 0. To overcome this, multiply 100x by 10. And doing so, we will get 1000x is equal to 123.33333 and so on. Now, if we subtract 100x from 1000x, we will get 900x is equal to 111. The digits after the decimal point will get cancelled. So, x will be equal to 111 divided by 900, which is 37 by 300 in its simplest form. So, basically our aim is to multiply with such a number such that the digits after the point will be same in both the numbers, so that at the time of subtracting we can get rid of them. As you keep practicing, you will understand by which number you have to multiply and subtract. Friends, now let me give you a trick with which you can convert these decimals into their p by q forms in 5 seconds. Yeah, only in 5 seconds. So concentrate well. Let's say we have to convert the number 0.123 bar only on 2 and 3 into its p by q form. First, we take the number 123, which is the number after the decimal point, and we subtract 1 from it, which is the non-recurring part. So, 123 minus 1 forms the numerator of this number. To find the denominator, we have to count the number of recurring digits and also the number of non-recurring digits. As we can clearly see, there are 2 recurring digits here. So in the denominator, we write 2 9s in the starting. And also, there is only 1 non-recurring digit here. So after the 2 9s, we mention a 0. So that's it. 0.123 bar is equal to 123 minus 1 divided by 990, which is nothing but 122 by 990. This time, in the number 0.123 bar, if the bar is only on 3, then again 123, the complete number, minus 12, the non-recurring part, which gives 111 as the numerator. As we can see, there is only 1 recurring digit. So only 19 in the denominator. And there are 2 non-recurring digits, so 2 zeros in the denominator. So the number 0.123 bar will be equal to 111 by 900. If the bar is on all the 3 digits, then we simply subtract 0 from the total number. That is, 0.123 bar will be equal to 123 minus 0 divided by 999, since all the 3 digits are recurring. I promise that with the help of this trick, you can convert in 5 seconds. Let me do that in 5 seconds. Suppose the number is 0.256 bar. So, 256, the total number, minus 2, the recurring part, divided by 990, since only 2 digits are recurring. So, the number is 254 by 990. See, we did it only in 5 seconds. Now, how can we convert a number such as 3.56 bar into its p by q form using the same trick? For this, write the number 3.56 bar as 3 plus 0.56 bar. Now we know how to convert 0.56 bar into p by q form with the help of this trick. So the number will be 56 minus 0 divided by 99. So the final number will be 3 plus 56 by 99, which is 353 divided by 99. Now try to convert this number 2.8976 and so on into its p by q form. Now I cannot use the previous method since the digits are not recurring. This is a decimal in which the digits are neither terminating nor recurring. So this cannot be converted into its p by q form. So we can conclude that this number cannot be represented in p by q form. And we know that if a number cannot be represented in p by q form, then it is an irrational number. So irrational numbers in their decimal representation are neither terminating nor recurring. Now here is the decimal representation of square root of 2. This can be found using the long division method. As we can clearly see, the digits are neither recurring nor terminating. So square root of 2 is an irrational number. We also learned that pi is an irrational number, and for some calculation purposes we use pi equal to 22 by 7. But the exact value of pi is 3.14159 and so on, which is neither terminating nor recurring. In this way, pi is an irrational number. Now here is a problem for you. Try to find any one irrational number between 1 by 4 and 1 by 3. We can find infinitely many irrational numbers between these two numbers. Let's convert these two numbers into their decimal forms. So in their decimal forms, 1 by 4 will be 0.25 and 1 by 3 will be 0.3 bar. Now we have to find an irrational number between these two numbers. So we have to find a number between 0.25 and 0.333 and so on, such that the digits of that number must neither terminate nor recur. So one such number could be 0.278714 and so on, and take care that the digits should not recur. Similarly, these are many more irrational numbers between those two numbers 1 by 4 and 1 by 3. In this way, we can find any number of irrational numbers between two rational numbers and also between two irrational numbers as well. So friends, that's all for today. In our next video, we will be discussing the arithmetic of irrational numbers. Till then, keep practicing.